Good morning, mathematicians. We are looking at our week 23 Monday column. To start, we are asked which whole number is this addition of decimal problem closest to. Notice, boys and girls, I've rewritten my decimals here so that we can think what is 4 and 2700. What is that closest to as a whole? Well, I would say that's about 4 wholes. Then I can look at 2 and 8100, and I know that is about 3. 4 plus 3 would equal 7. I am asked to explain reasoning, so I could say something like 4 and 27 hundredths is close to 4. 2 and 81 hundredths is close to 3. 4 plus 3 equals 7. It is close to 7. So, boys and girls, this is really asking you just to think about a reasonable answer, a close answer, but not an exact answer. That is for part I. Now, in part double I am asked to actually find the exact answer. When I add decimals, I line up my decimal point. 7 plus 1 is 8. 2 plus 8 is 10. Here's my 0. Carry my 1. 1 plus 4 plus 2 is 7. So my exact answer is 7 and 800. And sure enough, I can see that my about answer and my exact answer are very close. So that was a reasonable estimation. Let's go down to our division problem. We are asked to divide this with an area model as well as with partial quotients. So first of all, let's remind ourselves that within this entire rectangle, which I am outlining in orange, I am going to be sharing this dividend of 994. I'm going to share that into 7 groups equally. So let's start with thinking what could be a reasonable first take? Well, I could use up 700 of that 994, and that would be 100 groups of 7. But when I think about that, I still have 294 left to sort in this. Well, if I have 294 left, because I've already used 700 of this, I could go ahead and think about a group of 30 groups of 7, because 7 times 3 is 21, and then I have this 0 to the side. So certainly that was a good take because now I have exactly 84 left. 700 plus 210 plus 84 uses up all 994. And I just need to ask myself, well, how many groups of 7 did I get from 84? And that was 12. Boys and girls, with this, I have used up all 994 in my rectangle, and I see my quotient on the top. Let's think about the distributive property so we can see exactly what we did. Well, what we did was we had 700, right? And we divided that by 7, and we got an answer of 100. That was in this first rectangle. Then I had 210 and I divided it by 7, and I got an answer of 30. Now I have 84 remaining, and I divided that by 7, and I got 12. So now I have to join this together. 100 plus 30 plus 12 is 142. Boys and girls, that finishes this with the area method. I am asked down below to do it with partial quotients as well. I'm going to do it over here to the side just to give myself a little bit more space and hopefully make it easier for you to read. Now, I need to use up all 994 by dividing it into groups of 7. I'm going to do 7 times 100 first because that's going to use up 700. That's going to give me a difference of 294. So now I ask myself again, what would be a reasonable next Well, I'm going to do the idea of 7 times 3 and then add a 0 because 7 times 3 is 21, and then I can add my 0. I get a difference of 84. Now, 7 goes into 84 exactly 12 times. That is a memorized fact. So now I have used up all of this. When I join this together, I can see my answer is 132. Oop, actually, 142, excuse me, because I have my 30 plus my 12 here. So my answer is 142. My answer here and my answer here both agree. Let's go down to our next question with Fleshy Fred. Fleshy Fred has 12,000 rolls of toilet paper to distribute among 30 bathrooms. How many rolls will each bathroom receive? Check your work. Boys and girls, I see a good opportunity to think about my basic fact with zero trick. When I divide 12 by 3, I get an answer of 4. Now I'm going to look and see, well, there's 3 zeros outside the basic fact here. There's 1 0 outside the basic fact here. When I subtract, I get a difference of 2 zeros. That tells me that I need to add 2 zeros to my quotient. So my answer here is 400. Indeed, that makes sense because 400 times the 30 bathrooms would take me back to the idea that I had 12,000 rolls of toilet paper that I was supposed to distribute. Our last question for today is about neighbor numbers and thinking about how those neighbor numbers compare. It says a rubber chicken weighs this much. Notice I wrote the chicken's weight here. That is 800ths of a kilogram. A rubber duck weighs this much. That is 8/10 of a kilogram. How many times as much as the duck does the chicken weigh? So that is thinking about the chicken. How does the chicken with the 8 in the hundredths place compare to the duck with the 8 in the tenths place? Well, I know that it is only 1/10 of the weight. Because remember, boys and girls, neighbor numbers always have a relationship of 10 times bigger or 10 times smaller. And certainly this duck is 10 times smaller. My 8 is in the smaller neighbor place value. Now I'm going to ask myself the opposite. How many times as much as the chicken does the duck weigh? Well, this duck is 8/10 or 80 hundredths, whereas chicken is only 800ths. So I know it is 10 times the value. Boys and girls, that finishes out our Monday column for week 23.